Hello class, we're going to be talking about solving systems by using the substitution method. Now, this method is just like it sounds. You're substituting in a value or an expression into another variable. So, how do we solve these problems? Problem number 1, you have a system x plus y equals 5 and y equals 3 plus x. In the elimination method, I strongly encourage you guys to write your answers in standard form, but if that's not the case, you could use the substitution method to solve these problems. So we like it when we have a variable that's isolated. So in this case, is there an equation with the variable isolated or by itself? The answer is yes. So we'll go ahead and box in that answer. What you're going to have to do now is write the second equation is already solved for y, and that is 3 plus x. So y equals that value. What you're going to do is take this expression. Instead of giving a number, you actually have an expression this time. You're going to, plug this expression into this second expression, because you need equation. You need to have both of these equations related somehow, and the way to do that is you're going to be plugging in expressions into a different part of another equation. So what does that look like? Well, I'm going to take step 2. It says substitute. Wherever I see the y value, I want to replace it with this 3 plus x expression. So this is the first expression given to me. I'm going to plug in this green expression into this y. So this is what it's going to look like. X plus 3 plus x equals 5. You've substituted in. Now all you have to do next is solve the equation. So here I go. I'm going to copy down x plus 3 plus x equals 5. And I'm going to combine my terms. And I'll get my final answer of what x equals. So x equals 1. Just like when we learned about the elimination method, when you find one of your variables, you want to substitute it into the other equation, any of the original ones, to get the second value. So step 4, solve for the other variable by substituting the value from step 3. So x equals 1, I'm going to substitute into, I'll use this second equation because it's already solved. Y is already by itself, so if I plug in that 1, I'll easily get my y value. So y equals 3 plus x. So I found that x equals 1. I'm going to put that into my formula, or my equation. So my y value equals 4. So what I'm going to do now is put it into my ordered pair. So 1, 4. The last step that you want to do is check your work, and I've taught you how to do it in your calculator, so I'm going to go ahead and show you. Okay, so I pulled up my calculator here to show you that x equals 1, y is 4. That's what my solution is. So how do you check? You go back to the original formulas. I already did the first one for you here. X is 1 plus 4 equals 5. I need to get 5, and I did. So I know I did that correctly, but you have to check the second equation just to make sure. So y equals 3 plus x. X equals 1. So I did that. 3 plus 1 is 4. 4 equals 4. So that's how you know if you did it correctly. So that is the substitution method. I'm going to go ahead and flip over to the next page so that you guys can do more practice problems. Okay, so number 2, I have two equations. One of them is already solved for me and it's already isolated, so I'm going to go ahead and highlight this portion because this is what I'm going to be substituting in or replacing. So wherever I see the letter y in the top equation, I'm going to substitute this expression. In that case, this y is what I'm looking at. So I'm going to write in the original, I'm going to write in the first equation 4x minus 3 Now, instead of writing y, I'm going to use parentheses, and I'm going to replace the y with this expression, because this information is telling me that y equals these two terms. So I'm here, and all you have to do is solve this multi-step equation. This is why we learned it. We learned solving the beginning of the year. So I'm going to use the distributive property. I know I did this correctly because I have the same variables. You can't have two y's. We talked about having the same variables. You won't be able to solve your equation. So 19x plus 6 equals negative 13. X equals negative 1. So now that you found one of your variables, you need to use this substitution method and plug this number into any of the equations above. Now, I always try to go for one where y is already by itself. You can go ahead and do the first one. You'll still get the same answer, but I'm going to use the second one in this example. Okay, I went ahead and I plugged in negative 1 into my second equation here, and I've showed you my work in the green font. When I do that, I get the y value equals 3. So my answer is negative 1, comma 3. That's where these two equations meet if I were to graph them. But of course, you want to check your work to make sure you've done it correctly. So I've shown you here that if I plug in negative 1 in for x and 3 in for y for this first equation, on the left side it does equal negative 13, so I know I did it correctly there. For the second one, I plugged it into the part that's highlighted, so negative 5 times negative 1 minus 2. I ended up getting 3, so y equals this value of 3. I'm good to go. So that is the substitution method so far. If you want, you can pause this video for number 3, but I'm going to go ahead and get started on solving it. So this one is an interesting one because I have both equations that have y isolated. So the top one, it says y equals negative 4x plus 17, and the second one is also y equals 4x minus 15. You have to replace the expression. You're going to plug it in for y. So I'm going to look at this first one here. Y equals negative 4x plus 17. That expression I'm going to plug into the second one and replace that y. So all I have are just the x's and the numbers. I don't want any y's in this case. So I'm going to use the green marker to show you that the top equation, negative 4x plus 17, I'm going to plug it in to this y right here. So all I got to do now is copy down equals 4x minus 15. So now both of these equations are equal to each other. And so basically I put this expression into this y value in green equals 4x minus 15. Now I only have x's. So now you can go ahead and solve this equation. It's variables on both sides equation. And yeah. Okay, so I went ahead and did that. I got my answer. Well, one part of it is x equals 4. So now what you gotta do now is plug in that 4 into any of the equations and get the y value. I'm gonna go ahead and plug it into the first one. You can do any of these too, but I'm gonna use the first one to show my work. Okay, I solved my equation. I got y equals 1. So now what I'm going to do is write my answer in ordered pair form. 4, 1. And I want you to check your work. So put it in my calculator here to show you that the first equation, y equals negative 4x plus 17, I plugged in 4. I plugged 4 in this x, and I wanted to get the same y value as my answer, which was 1, and I did. So I got a check mark there. For the second one, 4 parentheses, 4 times 4 minus 15, I wanted to get the same y value of 1, which I did as well. So again, that's how we're solving these equations. So I'm going to go on to the next ones. You can pause this video and check back with me once you're done. Alright, so I highlighted my first equation, so wherever I see wherever I see the y, I'm going to substitute in 8x plus 17. And in the second equation, I have a y right before the 2, so this is how I'm going to start the problem. So I'm going to use a distributive property, combine like terms, and solve for x to continue on. Okay, you can go ahead and check my work here. I distributed, combined like terms, and then my x value is -3. So I have the first part. Now I'm going to substitute -3 into any of these equations. I'm going to go ahead and solve it on the first equation. Alright, and here you go. I got y equals -7, so my ordered pair is -3, -7, but again, you want to check your work. I went ahead and showed you on my calculator. I plugged in these values into both of these equations. The first one is y equals 8x plus 17. I ended up getting the y value -7, so check mark there. And the second one, I wanted to equal -5. That was the original equation, and I ended up doing that. So hopefully so far so good for you guys. I'm going to wrap it up with this problem. Alright, and here we go. Final answer for number 5. I plugged in x equals 2y plus 3. I plugged in this expression into x because in this case I have my x variable by itself, so that might be a situation for some of you. And then I have all y's. I solved it, y equals -1. I plugged this number into the first equation to get my x value, which I ended up getting 1. So my overall ordered pair is 1, -1. And I went ahead and checked my work, and I got both equations equaling the same number on the left to the right hand side. And that's how we solve these types of problems when you get an ordered pair. But obviously we do have situations in where we won't be having an answer, and that's the special cases on the bottom here. Something interesting is going to happen. So here we go. This is the special cases one. So one of these is going to be no solution, and one of them is going to be infinitely many solutions. For the bottom equation, I have x by itself, so this expression I'm going to plug in to the first one, which I did here, and all I'm going to do now is use the distributive property to solve this problem. I'm going to go ahead now and combine like terms. I have -4 and +4y. So when I put those together, those cancel out. So all I'm left with is 18 equals 18. This is a true statement. So my final answer is going to be all real numbers. This has infinitely many solutions. So more than one. So these lines are the same line. So this is the same line, and that's why it's all real numbers. So now let's look ahead at the last one. So this is going to probably show us the no solution. So I'm going to go ahead and pause this. So in this case, y is by itself. So I'm going to put that expression into the first one where I see the letter y, which I've done here. And I'm going to do the exact same thing from the previous problem, distribute. We get 6x plus 24. Okay, and then combine like terms. 6x minus 6x, that becomes 0x. And you're left with 24 equals 22. Well, this is false. This is not a true statement. So this has no solution. This has no solution here. So these two types of lines, if I were to graph them, are parallel lines. They don't have an intersection point, and they just have the same slope. They'll never meet. So that is the substitution method for you guys. Just make sure that you are isolating your variables if you need to. If not, you may use either the elimination method or the graphing method. Hope this video helps. If you have any questions for me, please ask me during class time. All right, I'll see you guys later. Bye.